Welcome, fellow chemists, to the first of two videos on the nomenclature of alkenes. We will look at cis, trans, and easy isomers in part 2. When naming the simple alkenes, all of the rules you applied when naming the alkanes apply again. The biggest change, however, is that there is a double bond which is considered a functional group, and the ending -ane has now become -ene. The first rule is very similar to what we have already seen. We are no longer looking for the longest continuous chain of carbons, but the longest that contains the double bond. The first path of 7 carbons simply skips it altogether. The second path ends with a double bond and is 6 carbons long. As before, with 6 carbons, its prefix is hex, except it is not hexane, but hexene. As we saw in the alkanes, the substituent is listed before the longest chain and numbered in the manner that gives the functional group the lowest possible number. You know how to name molecules with functional groups, so give this one a go. On this molecule, the double bond is our ene functional group. The parent containing that group is 6 carbons long, or hex, and we have an ethyl substituent. We want to ensure the location numbers are as small as possible, and with the double bond at the end of our parent, we start from there, giving it a 1, and the ethyl substituent is on carbon 2. With the substituents identified and locations determined, we can put everything together to develop the name of this molecule: 2-ethyl hex 1-ene. If there are multiple substituents, cite them alphabetically and give them the appropriate numbers after assigning the double bond the lowest one you can. With that in mind, give it a go and try naming the molecule on the screen now. Finding the parent is pretty easy, which is oct, and we find our double bond in there towards the right side. We also see 2 iodines, which means we will need the prefix di. And finally, there is an ethyl group near the middle. Numbering from the left, we get a 3 for the first iodine, a 4 for the ethyl, a 5 for the next iodine, and a 6 for our double bond. But from the right, we get a 2 for our double bond, a 4 for the first iodine, a 5 for the ethyl, and a 6 for the last iodine. We pick the direction with the 2 because it gives the double bond the lowest possible number. Once we have the substituents and locations identified, we can put the name together as with any other molecule, and we get 5-ethyl 4,6-diiodo oct-2-ene. If the double bond receives the same location number in both directions, move to the next substituent and give it the lowest possible number. This molecule pictured now may be rather large, but I do not think that naming it should trouble you. Identifying the parent is again relatively straightforward, and it is 10 carbons long, or dec. Our double bond ene is in the middle, and we have 2 substituents, methyl and ethyl. Finding the locations of these substituents from the left, we find our methyl group on position 5, our double bond on position 5, and our ethyl group on position 7. When we switch and count from the right, we find our ethyl group on position 4, our double bond is on position 5, and our methyl is on position 6. Since our double bond is always a 5, we want to pick the direction from the right, as it gives us our smallest number. With the substituents and locations determined for this molecule, we put together the name, which is 4-ethyl 6-methyl dec 5-ene. In a cyclic molecule, the double bond is considered between carbons 1 and 2 automatically. Then we number clockwise or anticlockwise to ensure the number for a substituent is as low as possible. So try naming this molecule now. You already know the basics, so give it a go. We have a 6-carbon parent ring, or cyclohex, our double bond ene, and we have a pair of bromines, which means we will need to use the prefix di. There's also a chlorine on the ring. We will check the locations clockwise and anticlockwise starting from our double bond, which is considered position 1. Going clockwise from position 1 for the bromine, we get a 4 for the chlorine and a 6 for the other bromine. But when we switch directions and go anti-clockwise, The first bromine is at position 2, the next bromine is at position 3, and the chlorine is at position 5. With 1 being the lowest number, we choose the clockwise direction. With all the substituents and locations identified, we can put together the name of this molecule, which is 1,6-dibromo-4-chloro-cyclohex-1-ene. If the double bond location is the same and the next substituent is also a tie, move to a third substituent to determine the proper direction that results in the smallest numbers. This is the final example for part 1, so give it a go naming the molecule on the screen. The 6-carbon parent, or hex, is pretty easy to spot, along with the double bond in the middle. There are a pair of methyl groups on this molecule, which means we need to use the numerical prefix di, and the final substituent is the chlorine. When we number the locations of these groups from the left, we get a 2, 3, 4, and a 5. When we switch directions and number the locations from the right, we get a 2, 3, another 3, and a 5. It may be difficult to spot, but it is actually the chlorine that has a smaller number when we go from the right. Now that we have determined the locations and substituents for this molecule, we can finally put together the name 3-chloro-2,5-dimethyl-hex-3-ene. There are plenty of organic molecules that have multiple functional groups. They're either 2 or more of the same group or combinations of them. Here on the left is a molecule without functional groups known as before an organic exam. On the right, we have multiple functional groups on a molecule called after an organic exam. If you do not get it, I am dying to tell you, but that will have to be a story for another time. To summarize basic alkene naming, the parent hydrocarbon is the longest chain containing the double bond. Ensure the double bond receives the lowest possible number. With multiple substituents, cite them alphabetically and give them the lowest numbers possible after giving the double bond the lowest you can. When numbering for both directions results in the same location for the double bond, ensure a substituent gets the lowest possible number. In a cyclic molecule, the double bond is considered position 1, 2 automatically. Then number clockwise or anti-clockwise to determine the direction that gives the lowest numbers. If the double bond and next substituent is a tie, move to a third substituent in order to determine the direction that gives the smallest possible numbers. In part 2, we will encounter cis and trans isomers of alkenes, as well as the E and Z isomers. Thank you very much for watching. If you enjoyed this video, please like and subscribe as I have more in development. Continuing with the channel recommendations, I have 2 where chemistry features often or all the time, Cody's Lab and Nile Red. I highly suggest the Precious Metal Refining series on Cody's Lab, and there are numerous organic chemistry experiments you can witness on Nile Red's channel. You'll find links to their channels and websites in the description. You will also find chemistry all of the time on this channel, and here are links to a couple of previous videos on alkane nomenclature in case you are in need of a refresher. Please feel free to get in touch with me via email, social media, or if you would like, make a request in the comments.